Congratulations. You've made it through about 40% of the material on the physics SSAT test. We finished kinetics, big four, collisions, whether they always conserve momentum. Sometimes they conserve energy because that's part of the work energy theorem. Impulse, which is really part of Newton's second law. We know Newton's laws. We know how to define power, two equations, and we know our conservation laws. That momentum is always conserved, be it angular momentum or linear momentum. And in an angular problem, if anything is rotating, all of the linear momenta must be put into angular momenta. Congratulations, you're 40% done. Please review your equations. I've written some of them down here. You know, we have our kinetic and potential energies, our big four in linear form and rotary form. I didn't write the rotary forms out for the other four. We also, although I didn't write it down, we also know the definition of acceleration is the change in velocity with time. And we also know that the velocity is the change in displacement with time. And we have our work energy theorem, our impulse, which comes directly from Newton's second law, which is F net equals ma. So we have that equation as well, Newton's second law. We know his first law is that objects continue doing what they're doing, sitting still or moving at constant velocity until a force acts on them. We have Newton's gravity, which he used to derive Kepler's laws. Kepler found them empirically, didn't derive them, just got the numbers and was able to show that this guy, r cubed over t squared, is constant. We also found expressions for tv cubed and rv squared, and we know they're constant. We don't much care what the constants are. We won't be asked that. We'll be asked questions that have to do in gravity with things like, suppose that I double the radius of a planet, what happens to the gravity? Well, r is on the bottom. If you double r, it becomes 2 squared or 4. The gravity falls to a fourth of what it was if the planet is twice as big but the same mass. So I didn't write the two big collision equations for inelastic collisions, but you should have all of these equations written down in some kind of log or book. You're keeping sort of a physics diary. Remember the range, if we land at the same altitude at which we fire something, that the range is the launch velocity v times the sine of 2 theta over g. And I expect you to remember, and it should be in your book, that this is 2 sine theta cos theta, which you would have learned in Algebra 2 or in pre-calculus. So somewhere in trigonometry, you've picked that up. We have our energies. We know that G at the surface of the Earth is 10 meters per second squared, and that doesn't violate Newton's law of gravity. In fact, since at the surface of the Earth, the force of gravity is mg, the gravitational constant big G times the mass of the Earth divided by the radius of the Earth squared must be 10 meters per second squared. We just don't bother to calculate that every time because a lot of what we do takes place at the surface of the Earth. So review your equations, and then we're going to do some real practice problems from actual SSAT physics tests. You'll find those in the library on the Fred Ebert channel on YouTube under the library that I've said real SSAT physics problems. So congratulations, you've come a long way. Left for us to do thermodynamics, waves, optics. Waves concern pendula and springs, and we'll also look at ray optics like lenses, mirrors, and we'll also study thermodynamics and gases, modern physics, that's to say Einstein's relativity, And don't worry, won't be deriving any of it, just using it. We'll learn that the speed limit in the universe is c, 3 times 10 to the 8th meters per second squared. And we'll also do a little bit of history. We've done that with Kepler and Bra, so we know that we have a little bit of history and lab work to review, but 40% of the work is done. It's pretty good. I'm real proud of you for sticking with it. And now it's time to, once you've reviewed your equations, go to the library for real SSAT physics problems and try your hand at them. Some of them are easy, some of them are hard, but you got to practice if you want to get that 800.